So let's get started. Today we're talking about applying LLMs to writing code. And Dan and I had a little bit of a synchronization issue this morning, and we ended up both adding in news of the day. So I'll let him do his, and then I'll do mine.
I've got just a couple of things real quick. So first off, I've mentioned this before, but on Friday is the HCI seminar, and this one looks pretty interesting. So it kind of is an extension of what Peter will be talking about today, although for visual effects. So this guy is coming from Adobe to talk about the new wave of Adobe AI tools. So check that out. News of the day is a new superintelligence team. And one of the things, so this is HCI and a different cloak. They're doing this specifically for medical diagnosis. So rather than doing AGI, which is general, they're doing superintelligence, which is not general. So they're taking the well-known AI mechanism of focusing on a domain. So just diagnosis. And what I found so interesting about this was that they were doing this because this is the classic AI trick. Don't try to do everything, just focus on one thing. So I also like at the bottom, they say, Microsoft plans to invest a, quote, lot of money, said Mustafa Suleyman. And Mustafa used to be at DeepMind. So he migrated over a while ago. Second thing, following up on the autonomous vehicles presentation of the other day, I saw this in the news today. XPeng, they've now got this G9, which they're planning on rolling out literally in China. It's going to be the first unmodified mass-produced EV to be a robotaxi. And I'm very interested to see how this is going to work out. I don't know. So if anybody sees an XPeng G9 news brief in the future, I'm curious about how well it's working. Let me know. But it's interesting to see that the rest of the world is also doing all the AI work that we're doing as well. And just for fun, on the realm of UI for vehicles, this was just launched, I guess this past week. Scout has announced their new Terra EV truck with physical buttons, damn it. Right? No more of this kind of touch screen kind of figure out. I don't know about you, when I'm driving and I've got a curly touch screen device, I do this, trying to figure out where the button part. So they've gone retro. Now that looks like a dash out of a 1950 Ford truck. But you know, everybody understands how it works, and it actually has a bunch of nice affordances. I wanted to point out one more thing, which is people are starting to send in email asking about, can we present on the 4th? Can we present on the 11th? That's fine. Two things to know about the final presentation. You need to turn in 2 parts, both your final report, in whatever form that is, and the slides for your presentation. Okay. Also, pick your date as soon as possible, because this is the spreadsheet. So I'll make that a little bit bigger so you can see it. You can put in TBD for your title or project description, but you need to do that. You need to solidify that sometime soon. And then you need to put in your people and choose your date, the 4th or the 11th, okay? So these are the 2 columns. This is going to be your final, the thing you turn in, and this is going to be the presentation you give on the presentation dates, okay? One other thing to note, these are all the slots available for the 4th. The pink ones are the slots available on the 11th. Notice that nobody signed up for them. Notice also that the 4th slots are running out fast. So if you have to be on the 4th, get your presentation project description in today as soon as possible. Otherwise, you won't have a choice. All right? I think that's it. Back to you.
All right, so my choice for news, there were some comparisons done, and it turns out this Google AI model did better at predicting hurricanes than other models, including sort of the main forecasting system. And I think that's interesting for a couple of reasons. So one is it's more efficient and it uses data in a better way, right? So with the existing models, kind of what they did is they said, we've got a couple differential equations for how we think the atmosphere works. And the way we're going to make it run better is by making the grid size on our simulation smaller and maybe gathering more measurements and then applying a more powerful supercomputer to crunching these numbers. And that's how the traditional approach goes. And it feels like they're asymptoting out, that they're not getting that much better, because using that approach, you can only go so far. Google can take different types of information beyond just these, at this point, the temperature and pressure is such and such, feed it into this AI that combines it in a way that nobody quite understands, but it's different than these very precise physical models. And it turns out this does better. And it also feels like it has a path to improve more in the future. So I think that's really interesting. Jensen Wang says China is going to win the AI race. I think he might be right in that. Certainly China's made big strides. Also, of course, everybody's got their own slant. And partially what he's saying is, get off my back with this regulation. And here's why you should do that. And so some of that I think is accurate and honest, and some of it is self-serving. Related to that, maybe the EU is pausing part of their landmark AI Act, right? So they had all these rules on what you could do with AI sort of based on consumer protection. But some of the people were pointing out, well, maybe it's also based on protection of competition from all these companies that are coming from the US and China and are not coming from the EU. And part of that backing off may be that we are now seeing companies in the EU. So Mistral in France, they're saying, well, maybe we don't need all these regulations. And Stellantis, you might not have heard of them, but basically they're a huge merger of a bunch of automobile companies, including Fiat and Peugeot, who are European companies. And they're saying, maybe we want to back off on this legislation. So those fights will continue. All right, so back to the topic. And some of you may have played with this, and some of you may know, it's pretty easy now to go in and just say, give a description, I want you to write some code, and it does it. So I said, make a website for a Stanford student who concentrated on human-centered AI and is looking for a job, and it does the HTML and the CSS and maybe some JavaScript and generates something, does a good job, and then you can iterate on that. So this is pretty new, just through the past couple of years, you can do this. I think it's okay. Those of you in the audience who are CS majors, there's still going to be jobs for you. Don't worry, don't panic. But it does mean that a lot of people who didn't have access to doing these kinds of things before can now do it. Okay, and I also think this is interesting because this issue of building an AI system that will automate part of all the process of writing code, it covers kind of all the issues that we've been talking about in this class about how to use AI for anything, right? So we're in this state where this AI can do amazing things, but they're not perfect. So you can't just hand it over and say, AI, write all my code. You have to worry about how do we get this to work? And so the whole AI project lifecycle that appears for any AI system definitely appears here. So here's all the questions, right? Do I have the right technology? I actually know something about coding that I don't know about in other areas. So is just using deep learning the right thing, right? So we made large language models because linguists had tried and failed for 50 years to write down a grammar of English, right? We didn't know what that grammar was, and deep learning could do it. With programming languages, we know exactly what the grammar is. And yet, these approaches tend not to use everything that we know, and instead use the same approach that we use with English. Is that the right thing? The technology is not mature, so we can't do full automation. Same as with self-driving cars. How do you get there? What's the human's role? How do you build trust with the users? This issue of vigilance fatigue we've seen before. If it gives the right answer 10 times in a row, then maybe you stop checking it, and the next time it puts in an error. And all these issues of privacy and security and intellectual property rights, they all show up here, just as they would in most of these AI systems. Okay, so what level of automation are we at, right? We have these 5 levels for self-driving cars. I think the same kind of idea applies here. So level 0 would be no automation. And what counts as no has changed over the years. So in 1957, the programming language Fortran replaced assembly code, and it was called an automatic coding system, right? So they would have said, oh, wow, we're really moving up that automation scale. And today we'd say Fortran is a bad and old and inexpressive literature. Then level 1 is doing a specific task, maybe auto completion of code, and we're definitely there. Level 2 is doing more complex tasks, maybe saying, well, I'm still going to write the main code, but then I want the AI system to write all the tests for me. Level 3, where I think mostly is where we're at now, is the humans and the AIs working together. The AI might make a mistake, but the human can help correct it. Level 4 would be driverless in specific situations. I think we're not quite there yet, although there's some things like if you say, well, I want to have something that optimizes database queries, or sort of one specific subset, you may be able to do full driverless, full automation there. And then level 5, we're definitely not there yet. Okay, so I want to ask you, what do you think? Say you're a product manager, and your company comes to you and say, we want to release some kind of AI writing code product, but given all these constraints, we're not sure what to do. What should we focus on? What can we build that will definitely help the users, won't go beyond the state of the art? What do you think we can do? And what should we not attempt to do? Because that might be dangerous. So talk to your neighbor for a few minutes and think about that. All right, let's bring it back together. What do you guys come up with? What useful product can we build with this amazing yet imperfect technology? Mhm. Yeah, so I think that's great. So this idea that maybe it's a tool earlier in the cycle to help you go faster, but you don't want to make a mistake pushing something out to users that's wrong, and so you want more checks in there. And software companies have been doing that for a long time, right? So I'm not allowed to push something to production before it's been code reviewed and tests have been run and all these other checks and balances. And the same should be true for AI. You shouldn't let it do that all by itself. Anybody else? Yeah.
I think the big ones are like actually using personal ID. That we've talked about is like having more autonomy in terms of how much code it writes at one time. So like now, like they've kind of done better with like the black box where they list out the different tasks that it's like having to check this complete. And it does each one, but it does it all together. So when you stop it, you kind of forget to train of thought. If there's an option where you can tell it to just go one pass at a time, or you can tell it to do it all at once, that would be really, really helpful. That's more control. And then that also allows you to go back in and fix problems as they come up, rather than like have cursor try to go to a huge database and find like the problem.
Yeah, I think that's important. We're going to talk about that a little bit more, but this idea of there are different timescales of interactions, right? And so we have, before AI, we had this technology of autocomplete, and you hit tab and it says, here's all the methods for this variable. And that's really got to come up in 100 milliseconds. If it takes any longer than that, it interrupts your flow. And it's simple, so we can do that. But if you have more AI in the loop and it's taking a couple seconds rather than 100 milliseconds, then that's a different kind of interaction. And that interaction still can be valuable. Like when we do pairs programming, you're talking back and forth and it takes a couple seconds for each interaction, and that's okay, but you should be clear that that's a different kind of interaction. And then there's this third kind that you were talking about with cursor of just saying, do all these things and I'll come back in 10 minutes or half an hour and you'll be done. So there are different time scales and different kinds of products and interactions for each of those. Now, you guys over here were talking about something for the learner rather than just for producing code. Can you tell me about that idea?
Yeah, so I guess like I was thinking like if there's like a AI writing code writing for like students, then it should like attempt to, or like not attempt to like give full solutions or implementations to students, but rather say guide them like to or it's or like give it some like syntax and things like that to like focus on like key.
Yeah. So there, I think, so the product is not writing code, or maybe that's part of the product, but another important part is making the user better and teaching them something and having them become a better programmer, rather than, some people are worried now that no one's going to learn to be an expert programmer because the machine's going to do it all for them. And we'll talk about some of that a little bit later on too. Okay, so here's some of the tasks that are possible. Maybe some of you talked about all that, but basically you can just go through all the parts of what it takes to code and say, is this a good target? And I won't read them one by one, but if you've done programming, you know that there's all these possibilities here, and we could focus on one or the other. Here's what I was talking about, this idea of code completion. It's a 25-year-old technology at least, and it's got to be really fast. And you can train it on an existing code base. It can be personalized or localized, but mostly it's just doing lookup and then showing you the possibilities. What could we do with the deep learning model to do better? Well, one, we could do re-ranking, right? So, here, rather than just saying, here's all the possible methods, we could say, yes, let's fetch all the possible ones, but then let's put the most likely ones first. We can check for some syntactic and semantic correctness. Will this actually compile? We can focus on making it faster and making the UI be unobtrusive. We can focus on continuity of saying, I don't want to interrupt the programmer. If the programmer is in the flow, I want to help them to continue. If they're stuck, then I want to get them unstuck. So I guess the deeper question is it even possible for a deep neural network to write code and do a really good job of that? And I would like this quote from Edgar Dijkstra, one of our most acclaimed computer scientists. He's got this algorithm named after him, Dijkstra's algorithm. And he said, in the discrete world of computing, there's no meaningful metric in which small changes and small effects go hand in hand, and there never will be. Well, what he meant by that is, unlike most things in the physical world, you could take this code that's megabytes of code, and you change one bit, and then the whole thing completely changes. It does something else, or it crashes. And in the real physical world, you make a tiny change, you usually have a tiny outcome. And code is just different from that. And that's worrisome if you're trying to make a deep neural network, because we do it all by gradient descent, and we assume if we make a small change in our program, we're going to have a small change in its error, and then we minimize that error. And if he's right, then gradient descent isn't going to work, and this whole thing is going to fail. So that's his distinguished opinion. Here's another opinion from Arthur C. Clarke, science fiction writer, who says, when a distinguished elderly scientist states that something is possible, he's almost certainly right. When he says it's impossible, he's very probably wrong. And I think in this case, Dijkstra was proved to be wrong. Fortunately for him, he died before he had to take his words back. I'll go to this other expert, Ken Thompson, one of the authors of Unix, who said, when in doubt, use brute force. And our GPUs and TPUs says, yeah, I got this. So Dijkstra's right that there are programs for which you change one bit and the whole thing changes. But most of what we write is not like that. So a couple of things are like that, but just stay away from those. Most of the things we write is, we look at the source code, you make a small change, it results in a small change in the output, and we are able to do gradient descent and improve based on that. So way back in ancient history in 2023, Andrei Karpathy says the hottest new programming language is English. He expanded on that in February of this year, invented this term vibe coding, of saying, I'm just going to do this stuff and I'm going to not even look at the code and it's all going to work. And I think that's great. I think he's, in some sense, maybe kidding himself a little bit, right? So part of the reason it works so well for him is because he is an expert programmer. And so when he gives a prompt, he gives a better prompt than somebody that doesn't know how to program, because he has in his mind where the program's going and he can help lead the system there. And he says he doesn't look at the code, and I don't think he's lying, right? So he doesn't look at the code line by line, but I think, the system can write a couple hundred lines and he can just glance at it for a second and say, no, that doesn't look right. Let me try again. And so having that expertise of the human in the loop, I think really makes a difference. But he is right that the system is doing most of the coding. He's not doing most of it. Okay, and now we're all getting a chance to do it, right? So we're going to do this live. And some of you may already have accounts, some of you may have already done this, and so use whatever system you like. I just looked at it and I thought the easiest one, especially if you haven't signed up yet, seems to be the least friction to signing up is claude.ai/new. So do this either by yourself, or I think it's probably better to do it with a neighbor, so 2 or 3 of you together. And certainly, if you've only got a phone, go get somebody with a laptop and go to claude.ai/new or your favorite place, and we're all going to invent an app. So I did it. So my prompt was invent a casual word game, something maybe like Wordle, but different, and implement it and let me play. And that was it. That was the whole prompt. It came up with this thing. There's a little app here that you could run. And the game was change from one word to another by chain of words where you change one letter at a time. I don't know if that counts as invention, because I think I've seen that before. But putting it into an app, I guess, counts as invention. So I want to change cold to warm by changing one letter at a time and have multiple steps. And you build the app and you type in a word and you hit submit. And it all runs to some extent. So come up with an idea. What's an app you want to build? And start doing it. See if it works. We'll see how it goes, but yeah, it could be like 10 minutes or so, right? So this is going to be longer than the 2-minute discussion. Yeah, yeah.
Compared to the infrastructure investment, my question is, are they like they're not actually
It's cool.
yeah,
I guess you just wrote something.
Yeah. Because I feel like for the longest time, it's like when you spit out. And even as a more limited things that I check. Yeah.
Yeah.
That's a great idea. We use, I think, once a week.
Wait, it was doing well, but then.
This free? Yeah, but then there's also. So you gotta. Yeah. Maybe reduce this. That was pretty quick.
No, actually, it's like.
This is probably. How do I like it? Once you build something. It's great. Want to export it?
I think those do. There are too many.
So that's interesting. Export this.
I think that literally is.
So I'm expanding the work.
Gotta be.
It's like, I feel like it's something about awesome. Like, why can't we also go there? So to do yeah. But if all like, it'll just take like
I know.
it's just not like the best. I don't know, like I just
Yeah.
at the beginning, it's like so I just
Yeah. Oh, no.
Okay, sounds like things have quieted down a little bit. It only took 8 minutes to, and looks like most people made an app. That's pretty cool. I want to show you, so you keep doing, if you're not done and you're into it, you can keep going. But I want to show you how my app went. So I came up with this thing. It has this interface, not beautiful, but it's okay. But then I looked a little bit closer, and here's the code. It looks all right, but there are a couple issues here. So one is, it says you're supposed to change one word at a time. And one of the examples is going from goad to ward. What? That's not right. That's a whole lot of changes at once. And all the other ones, all the other examples, every step was a valid step, changing one letter, and then all of a sudden it did that. So what's going on there? That was really weird. And then the other thing, which may be a kind of a minor thing, but it has these lists of legal words that you could use. And I think maybe what it did is it said, let me only list the words that work for the examples that I chose. But I played the game and I chose a very common word that was not in their list, right? And they only had like 300 words. I think they should have had 3,000 words, and that would have been better. So, it's kind of okay. And I could have done some iterations and I could have fixed that and could have gotten it better. So what'd you guys come up with? Who wants to share something that they did? I know you, yeah, go ahead.
We reinvented the Nokia snake.
Oh, yeah, yeah.
Very nice.
Snake corner over there, Alexis did it as well.
Uh-huh. And it worked? Uh-huh. So I have an anecdote of a time I played Snake in real life. My daughter was very little, and there were a bunch of Girl Scouts sitting around and playing Duck, Duck, Go, where you tap one person on. Right. The actual physical game. The idea is you go around to each person, you say goose, 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 and then you say duck, and then they're supposed to chase you. They're supposed to get up and chase you. And I said, I'm going to change the rules a little bit, and I'm going to pat everybody and say, you're all chasing me. And then I'm running around and I realized I've got a snake behind me. They're following each other one by one. And I can't just go right back to the start because the last snake will then get me. So I have to go in a circuitous path, and all the snakes has followed the person in front of me and allowed me to get back to the start. So
You did the Congo one.
exactly. Okay. Who else had a fun game that they played? Or what you come up with?
This Flappy Bird.
Yeah.
I did a lot of run.
Ah. Cool. And I think there was another Flappy Bird over here somewhere. Yeah. How did yours work? And what'd you run it in? Yeah. Which did you use Claude or what did you use? So weird, Claude. So maybe there's something about the exact words of the prompt, or maybe it was just random choices that it worked for you and it didn't work for you. But that's a common lesson, is that you don't know when it's going to work and when it's not going to work. Anybody else have one they want to talk about? Okay, well, I hope you, yeah.
One thing that the common thread, at least on that side of the room, was what does it take to export this?
Yeah.
Externally.
Yeah.
And some people have found that there were dependencies that were not obvious and had issues with that.
Yeah. And some people were using other services and so on. And so I thought Claude was the best to just get going in 10 minutes, but other versions are better for other aspects. Okay. So how does it work? How does it do this stuff? That's pretty cool. So there's this interesting paper by Andrei Karpathy in which he kind of goes through and shows, he looks at the different neurons within his net and shows what they trigger on. And he says most of them you can't really tell, right? So here's the different letters. Here's how much they excite this particular cell. It looks completely random. Some of them you can figure out exactly what they're doing, right? So there's one that turns on within quotes and comment characters, right? So it's figured out the syntax of the language of how comments work and implemented that in a neuron within the net. And here's one that basically counts the indentation level, right? So this is something that, is well known. You can't do this with a finite state grammar. And technically you can't do it with a neural net of a limited depth, right? So if I went to depth 1,000, probably the neural net would fail, but Most programs only go to 10 or 20 and it works fine. Okay. So how could neural nets understand programs? So this is back in 2021. I thought this was an interesting paper. And it says, here's all the things you could look at. We could train by the source code. We could get the parser to output an abstract syntax tree. We could look at the assembly code that's generated. We could trace it and look at the execution flow. We can look at the design docs and all these other things. So all these different representations in 2021, people were experimenting with what else do we want to look at? And then it turns out in 2025, right, so here's the diagram from that paper of all the things they looked at. In 2025, it says, no, we don't need any of that. So yeah, we could look at the compiled code, but we don't need to. If we have enough of the source code, that always wins, right? And so all these clever ideas of how to outsmart things and how to bring in these additional knowledge sources, they're all swamped by just saying, pour more code through it and it will get better. Okay, so what is it good at? So most of you had this experience. It could kind of build a game. Maybe it worked well. Maybe it was perfect. Maybe there were some flaws. I think it's really good at well-known algorithms, right? So here's an example. Write a Python program to solve the set cover problem, a standard computer science algorithm problem, and it does a decent job. But I also could have done a search on GitHub or something and found similar code. So why would I do this rather than just search and find it on GitHub? And I think the reason is because maybe it's not the exact version that I want, right? So I can say, well, make the subsets have weights rather than having every element be the same. Maybe I want them to be different. And it might have been harder to express that if I'm just doing a search for an algorithm like this. Or then I can say, make it more efficient. And that might or might not work. In this case, it didn't work, right? So what's going on here is they said, okay, I want to make it more efficient. It'd probably be good to sort them so that I get the best one first, but it doesn't sort inside the loop, which just actually makes it slower rather than more efficient. And what it should have done is done to sort outside the loop and maintain a priority queue, and that would have made it faster. Then I could say, well, maybe I want to have a name associated with each subset rather than just a list of elements, and I can do that, and it did that right. So this ability, it's easy to retrieve an algorithm from all the code that's out there, but if you want to customize it to do exactly what you want, this seems like a better interface. So what about larger apps? So I played around a lot with these smaller types of things. With my colleague, Peter Dannenberg, and I over the last couple of weeks, we actually built a larger thing. And we wanted to build this interactive learning system that's kind of like Notebook LM, but it's focused on making you learn better. And so we built it, dumped some pedagogical book chapters or Python notebooks in, and told it to extract a knowledge graph of all the concepts and their prerequisites. It does a pretty good job of that. We were surprised at how well it did. Sometimes it says there's a prerequisite link from A to B, when actually it was just, I talked about A before I talked about B, and I could have talked about it in the other order, but mostly it gets it right. Builds that kind of graph, builds a learning objectives and key insights summary, and then allows you to have a dialogue and allows you to run code and see if it works and so on. And basically, we just threw this together. Here's more of the interactions. And it mostly worked. And sometimes we get things a little bit wrong. We had to fix it. But, you know, I don't know Node and NPM, but it was able to generate code that worked. And so this changed the capabilities for what I could do. And I think a lot of people are seeing that. Okay. Here's another experiment I did. So over the last couple of years, there's been a lot of talk of, do LLMs have a theory of mind? By that, I mean, do they understand what I'm thinking, and can they use that in their thinking and vice versa? And I thought there's a lot of sort of logic puzzles that work like that. And so I told it, write a Python program to solve the Cheryl's birthday problem. So I don't know if you remember that, but a couple of years ago, there was this problem, and Cheryl tells one friend the month of her birthday and the other friend the day of her birthday, and says it's one of these 10 possibilities. And the first friend says, well, then I don't know what it is. And the second one says, I don't know either. And then the first says, well, because of that, now I know. Right? So it's they have to model each other's state of knowledge, come to the conclusion. So I tried 9 LLMs in 2024 to see if they could do this. And they all were very confident about writing code, and they all got the wrong answer because they all conflated what I know and what somebody else knows. But then I ran it again in 2025, and now half of them get it, right? So it's progress. These things are getting better at a very fast rate. Here's another example, similar kind of thing. My friend Weiwa submitted this again in 2024, this math question: list all the ways in which 3 distinct positive integers have a product of 108. And it turns out these are the ones. And he asked a bunch of LLMs, and I extended the list to the 9 I had, and only 2 of them could get that right. And one of the mistakes they made is they all said, well, it's a good idea to figure out the prime factorization of 108. 2 times 2 times 3 times 3 times 3. And now what we got to do is we got to take these numbers and put them into 3 subsets. But some of them kind of forgot that you could have the empty subset, or equivalently, that the number 1 is a factor of 108. And so they got it wrong for that reason or for other reasons. So 2 out of 9 succeeded for this math question. But then I turned it into a programming question to say, write a program to list all the ways in which 3 distinct positive integers have a product of 108. And now 7 of 9 got them in 2024, and 8 of 9 in 2025. And I think what's going on here is so 1 is kind of strange when it comes to prime numbers and multiplication, right? We're not quite sure, is 1 a prime or not? But in programming, you always say for I equals 1 to n. You never say for I equals 2 to n, right? So it was easy in the math question to forget 1. In the programming question, it was harder to forget 1. And I think in general, there are different representations, different ways of talking that will be better for some problems than others. The language of math is amazing. It can let you do a bunch of things. And so is the language of programming. It lets you do overlapping but different types of things. And the way LLMs work is they do thinking on their own, but they have to have some way to represent their thinking in some kind of format. And that's why they do better when you say, use this think aloud protocol, show your intermediate work. And there are some problems for which a programming language is a really great intermediate format. And here's an example. OpenAI Codex did that. So again, they were solving math problems, but they said, we're going to do an intermediate step where we generate a program and solve the math problem through that. And I think this is important for 2 reasons. One, it kind of focuses this reasoning. It's important for it to have scratch paper that it can write on. And often writing that as a program is a better way to do it than trying to write it as English statements or as math statements. And secondly, you can do voting with programs, right? You can have it say, I'm going to generate 10 possible programs. I'm going to run them all. Oh, look, 8 of them gave the same answer. Maybe that's the right answer. Whereas if I said, generate 10 paragraphs or generate 10 math statements, I can't execute them. So I can't tell, are they agreeing or are they disagreeing? And so that's the advantages of using programs as an intermediate representation. Now, so I said the way you succeed is by piling in more and more code and training on it. Inevitably, we run into these intellectual property issues. So GitHub files lawsuit over Copilot. It's saying you weren't following all the licensing agreements, right? So we have this code. Some of them have common commons or some other kind of licensing agreement associated with them. Copilot copied all that code and maybe violated some of those licensing agreements. And so there's issues over that. So I want you to take a couple minutes, talk to your neighbor. What do you think's okay in terms of intellectual property with code? As we have all this code that is open source, that's posted up there. Is it okay for an AI program to read this public source code? Is it okay to learn from that? Is it okay to store a copy? Is it okay for it to generate code that's similar, right? So a lot of you people generated code to play Wordle or Flappy Birds that might have been similar to other code. Is it okay to generate an exact copy? What do you think is legal or illegal, and what do you think should be allowed just by norms rather than by law? Go ahead and discuss.
I would ask if they had
Another question is. I assume they have not redone the base training. They just haven't been.
All right.
Where's our bell?
Yeah. Yeah, who stole the bell? All right. Let's wrap that up. So all these issues, in some sense, are the same for code as they are for any other training data that's out on the web. But in another sense, they're different, right? Because my random blog post or my restaurant review, maybe that's technically my intellectual property, but it doesn't feel like that has much value to it. Whereas code has been proven to have very strong and sometimes very large value. So in that sense, it feels different. So what did you guys discuss and what conclusions did you come to?
It's just really clear what we mean by always first code.
Yeah, so I think that's right, right? And I think one of the issues that does make it confusing, and one reason why GitHub was in the middle of this, is because it is a common repository in which there's a lot of code, and a lot of it is visible. You are allowed to make private repositories in GitHub that nobody can see, but a lot of them are public, and yet they have this license that restricts what you can do with it. And I think that's different than a lot of other sources.
A group of guys here in the middle have an interesting thought about citations. What do you say about that?
Yeah, I mean, basically we're saying that if you think about it, like what a human can do pretty much all of these except for 4 and 5.
Yeah.
Human would have to cite those.
Mhm.
If it's like copying exact code or getting those ideas from someone else.
Yeah.
So saying that an AI should be able to do whatever it needs to do. It should be able to do all the same things except 4 and 5 don't have to cite. But then the idea came up that AI gets its ideas from a lot of different places, so citations become pretty confusing. Because every like couple lines of code, it would be a new citation for a new place that it got its information.
Yeah, yeah, I think that's right. I think a couple issues with that, right? So one is, where are they going to put the citation, right? So if I publish a paper, it's clear, if I borrowed something, I'm definitely going to put a citation there. But if AI generates Flappy Birds, it doesn't feel like there's a place to put that citation, right? Maybe there could be footnotes somewhere, but nobody's going to look at them. So that seems less likely. Then there have been these big issues, even before AI, of what are you allowed to copy and not copy, right? So when, for example, when Google wanted to make the Android operating system, they wanted to do it in Java, and they went to the owners of Java and tried to work out a licensing agreement, but they couldn't get a licensing agreement that worked, right? They said, yeah, we could pay you this amount if we were charging money for every copy of the operating system, but we want to give it away for free, so we can't pay you a lot per copy. And so Google decided, we're just going to re-implement Java from scratch. And we're going to put in these clean rooms where it's very clear that nobody can look at the source code from Java, and they have to rewrite it on their own. And they did that, and they got sued anyways. And one of the pieces of evidence was saying, here's this 6-line method that's the same in the Java implementation and your implementation. And basically, it says, if X is less than 0, then do this error message, and if it's greater than N, do this error message, else do the right thing. And it kind of felt like, well, anybody could write that code. And it's just, you could write it slightly different, or you could write it exactly the same, but it's still the same idea, and any programmer would have come up with something similar. But that was sort of my opinion as a programmer, but the legal opinions, they look at it differently. And I think we still haven't resolved all those types of issues. Okay. So programming contests. And we'll get to some recent big wins, but this is from Alpha Code, which I guess is ancient history now, probably 2023. And they entered these contests and did well. And this was their primary example. They said, here's the 50 examples that we worked on. You can look at all of them and look at the code for all of them, but this is the one we're going to talk about the most. And this is what the input to the program looks like. So there's an English language description, and then there's sort of a formal input and expected output. And basically what they're asking is, they're saying, we're going to pass you 2 strings, S and T, and we're going to ask you, could you generate the string T by typing the characters in S, but you have the option for any of the characters to type a backspace instead of typing the character. So I give you A, B, A, B, A, and I want you to generate BA, and you could do that by substituting a backspace for the first 3 characters and then just typing BA, and that would give you the output. So then you should say yes. And there might have been other ways in which you could have put the backspaces in different places and get the right answer. So here's the program they came up with. So the system came out with this code, and then they put annotations on the side describing what the program does. And yes, it's right. It works 100% of the time. But before anybody's going to check in code into my repository, they have to go through code review. So I did a code review, and basically almost every line I would want them to change it. So there's a bunch of stuff here. A lot of them is sort of style type issues, and that would be easy to change. Some of them are a little bit deeper than that. And again, the program's 100% right. I just don't like it. And here's one thing. So they they're dealing with these stacks of characters A and B, and they initialize this stack C to be the empty stack. And then when they pop something off of stack B, they store it onto stack C. And I can see where they would get that, because that happens a lot of times. You're dealing with stacks, you pop something off, they say, I better save this somewhere. I might need it later. But they don't use C anywhere else in the entire program, right? And I know programmers that write like that, and I don't want to hire them. And maybe this is inevitable, right? Because they train this on a lot of code, and half the code was written by people who are below average. So. All right, and then this is kind of interesting. You could go to that website and you can play with it, and it shows you at each point what it's thinking of might come next. So you say for blank in range T, it's saying, well, my first guess is I is the most common iterator, and then underscore is sometimes used in Python when you don't care about the value of the variable. And then there's these other possibilities, and you go through and sort of figure out how it's thinking. So I showed you the program I didn't like. I'd rather have a program like this. I think this is a lot simpler, and it should be able to get there. I'd also like to be able to say, well, generate a bunch of test cases. The program gave me 4 test cases. I don't think that's enough. Generate a bunch of other ones and make them cover all the possibilities. Do that automatically for me. I think that would be good. And then I'd like to say, well, I had some sort of optimizations in the program, but I'm not sure those optimizations would always work. So have a system that's slow, but obviously correct, right? So I say, generate all possible outputs from the source, all possible ways of using a backspace or not, and then say, is the target one of those possibilities, right? So this is an exponentially slow algorithm, but if this gives the same answer as the other algorithm, that's more evidence that I got it right. And so I'd like to be able to get my system to do these things for me, right? I mean, it was too hard for me to write this code, but I could ask it, prove to me that it's correct by showing that in this degenerate case. And then we'll skip through some of this, but these are sort of all the types of questions that I want to see. If I was doing this, I might ask these questions of myself. If I was doing pair programming, I might ask this of my partner. I want the system to be able to engage in conversations and do all this. I don't just want to see the code that's correct. I want code that gives me more confidence in it. So how well does this work? In 2022, it looked like a 5 to 10% improvement. In 2023, another study got 40%. In 2025, another study said 57%. Looks like it's going up, but there are other ones, and these studies are all over the map. And it really depends on exactly what you're measuring and exactly who's measuring it and what their setup is and what they're trying to do and so on. But it does seem like there is a lot of progress here. But here's a study that says there was a 41% increase in bugs, right? So this was people going too fast and maybe getting ahead of themselves and building up that technical debt. Here's another one that says large language models can outperform human programmers. At this international programming competition, so this is a lot more serious than what AlphaCode did in 2023. Here in 2025, Gemini did solve this problem that no human team could solve, and OpenAI had a similar performance. So they both did well. OpenAI actually did a little bit better, but Gemini competed in the actual competition And OpenAI sort of did it on the side and said, we think we scored a perfect score. And so it's your choice which one of those you want to believe more. Okay. And I think something I think is really interesting is what programming language should we be using, right? So in the early days of programming, we said, we're going to program an assembly language because the programmers are cheap, but computers are big and expensive, and so we want to make sure it's super efficient. And then we said, well, now we're going to program mostly in C, which is a compromise between speed to the programmer and speed for the computer. Now we program in Python, which is not very efficient in terms of using the machine resources, but is better for the programmer. In the future, we want something that's good for the hardware, for the human programmer, and for the LLM. And so what should that be like? And one argument is, well, it should be Python and JavaScript because those are the languages that we have the most training data on. So those are the languages we'll do the best. Counter argument is, well, it's easy to translate between languages. So maybe we could use something else. Maybe we should use ones with the most explicit information, right? So in Python, if you don't have type declarations, you know less about the program. A language that's more strongly typed, you know more about it. Maybe that would be better. Or maybe something completely new. And here's a map of things that people are experimenting with. And mostly comes down to probabilistic programming and differential programming. And I think this really speaks to what are the types of things we want to solve. If we're trying to solve simulations in the real world of hurricanes or whatever, then our traditional languages aren't that good. Right? So our traditional languages are built on things like if statements. If X is true, then do Y, else do Z. In the real world, we rarely know something 100% certain. And so we can build in at the application level, well, I'm going to have probability distributions, and I'm going to have uncertainty and so on. But that's on top of the language. And this idea of probabilistic programming is we should build that into the language. So an if statement, rather than just saying true or false, says we're going to deal with a whole probability distribution. And then differentiable programming says, I'm going to write a program, it's going to have a bunch of parameters in it, and then I can automatically say, choose the right parameters to make the system run better. This could have gone in the news of the day, but I'm putting it here. And this is a proposal for software that's more modular and can fit together better using these things like LLMs, right? And their point here is you have things that seem kind of simple, right? So I build this app and there's a button. So a button should be one thing. But the way we write code today, a button isn't one thing, right? So there's a button and you press it and then that calls something and that makes a remote call to another computer and then it responds and then you process the response and so on. So a button doesn't stand alone, it stands connected to all these other things. And the proposal is, can we write software that separates that out more to make each of those components more independent? This book by Hansen and Sussman, Software Design for Flexibility, says one should not have to modify a working program, one should be able to add to it. And we don't do that, right? We modify programs all the time when we want to make it better. And they're saying, if we made it modular enough, we wouldn't have to do that. We just have to say, yes, here's the program you had before. Yes, and it should also do this thing without having to delete what you did before. Then they also say, compare our built software to biological systems. Say biological systems use contextual signals that are informative rather than imperative. There's no master commander saying what each part must do, right? So the cells of my body communicate with each other in ways that I don't understand. And there is no one central processor that says at this step, this cell's got to do the next thing. They all interact with each other. And we are building software that's more complex, and maybe it seems more like a biological system. So maybe we need programming languages that support that. And Kevin Kelly has a more sort of philosophical take on that, saying all is flux, nothing is finished. That means processes are more important than products. And so we should optimize how to make that process easy so that we can make the changes and have our programs evolve. So let's stop there and fill out the DP form. Yeah, I know that it's alpha. Yeah, alpha involved. Yeah, it's good. I just put you on it. I don't know what the unit is. It's not a character. It's a function. Yeah, I don't know. I don't know. It's like playing. I prefer what you take out of first. And that's not I never did. So I'm really curious. Just yeah. Or more clever solutions. Yeah. Better. You know, if you were observing the progress of evolution, billion years, we're still stuck at one cell animals. That's right. That's right. Let's shut this down. It's not over. Yeah. Yeah.